पिला माने myself Dr. B.K. Mahanti welcome you for this session. In the last class I have told you about coordination compounds nomenclature and one-notch coordination theory. In this class I will start isomerism and bondings in coordination compounds, which is very interesting chapter. This is isomerism and bondings in coordination compounds. So first we will discuss isomerism. Isomerism. In the isomerism, having same molecular formula, but different arrangement of atoms. Different arrangement of atoms. Atoms are called isomers, and the phenomenon is known as isomerism. The phenomenon is known as isomerism. In the different types of isomerism, structural isomerism, stereoisomerism. Two types, mainly two types in coordination compounds. In the structural isomerism, again divided into number one, ionization isomerism, hydrate isomerism, which is called also solvate. Three, linkage isomerism, four, coordination isomerism, which are there are other isomerism there which are not so important. Coordination isomerism. Mainly we discuss these four types mainly. First, we should discuss ionization isomerism. Ionization isomerism it gives different ions. It gives different ions in solution. Different ions in solution. This point is most important. The complex giving different ions in solution, but the compounds giving different ions in solution are called ionization isomer. Let us discuss the compound CO NH3 pair SO4. With comparison with, we may compare CO NH3 SO4 this complex part in Br. Different ions, fine, look at here CO NH3 Br plus SO4 minus. Same molecular formula. Both have same molecular formula, but here CO NH3 SO4 plus Br minus. Now come, these two are called ionization isomer because they give different ions in solution. Here you give sulfate ion, here you give bromide ion. Here the plus, it is plus charge. So different ions in solution is, so here outside of the coordination sphere, which is ionizable, comes inside and the non-ionizable go to that side. Then second point, second isomer is hydration isomer. Hydration isomer is due to change in water molecules. change in water molecules inside the coordination sphere, inside the coordination sphere, coordination sphere. May I give example is hydrogen isomer, example CO H2O6 Cl3. The isomer is CO H2O5 Cl2. Now the same molecular formula, but here 5 water molecules, here is 6 water molecules. The change of water molecule. Again I may write this CO H2O4 Cl2 Cl. So these all are the examples of hydrate isomer. Third is linkage isomer. Linkage isomer. Linkage isomer, that is for ligands having both, that is called ambidextrous ligand. In the last class I have told you ambidextrous ligand. In that case N's nitrite, suppose NO. The linkage may be done through nitrogen or through oxygen. If through nitrogen, that is nitro-N. If through oxygen, linkage is through oxygen, that is nitro-O. Either linkage through nitrogen, the complex name will change. Give an example, we may write CO or Cr NH3 NO2 2Cl2. Here if the linkage may be either through nitrogen, or you may write Cr NH3 ONO Cl2. So this Cr direct linkage through ONO. In that case, chromium linkage through NO. These are the all other NH3, so on, NH3 like this. So these two are different complex. One is nitro-O, one is another is nitro-N. The other one is coordination isomer. Coordination isomer. In the coordination isomer, both cation and anion complex, both cationic and anionic complex are present. So CO NH3 Cr CN6. So this part is cationic complex plus 3 cobalt, here is chromium plus 3. So this is anionic part and this is cationic part. Here same molecular formula, we may write this also, Cr NH3 CO CN6. Now this change of ligand from chromium to cobalt, and the chromium will be cation, ammonia parts there, and this is your anion. So this isomer is called coordination isomer. Because of pachar dabo coordination isomer, which is hydrate isomer, which is coordination isomer, you may answer like this, giving the examples. Now stereoisomer Go to geometrical isomer. First one is geometrical. Geometrical isomer. I will discuss in coordination 4 and coordination 6. Coordination number 4. Let us discuss geometrical isomer of coordination number of 4. Number of 4. 4 means there are 4 ligands are there. Ma4 type. Ma4 type. Where M is the central metal atom or ion. Central metal atom or ion. And A is the ligand. You may write example is PT NH3 plus. So this PT is M, central metal ion, and NH3 ligand, NH3 fluoride. Whether we get different structure or not, we will find out. So in Ma4 type, we get M A. It is only possible in square planar. We will discuss in square planar structure. Square planar structure we will see. जत्ते चेंज कले जहाँ कले भी विल गेट वन स्ट्रक्चर हम दीटा स्ट्रक्चर पाइबा Ma4 so PT NH3 only we get one structure, therefore it will not give geometrical isomer. Then type Ma3B type. Ma3B type. Example is PT NH3 Cl plus. In this case, we find M A B जिते चेंज कले भी हम तीनटा ए गोटे साइड पाइबा गोटे बी रहिबो ताले हमें चेंज जिते स्ट्रक्चर चेंज कले बा जिते अरेंजमेंट कले हम ओनली गेट वन स्ट्रक्चर ओनली वी गेट वन अरेंजमेंट no change of other structure, we can't find other structure. Therefore Ma35, that's the example, it will not give any geometrical isomer, does not give geometrical isomer. Now Ma2B2 type. Ma2B2 type. Two types of ligands are there. 2A ligands and 2B ligands. In this case, we get two types. We get M A B B. So this A remains same side, B B remains same side. So this is called cis isomer. This is called cis isomer. And this M opposite direction M A B B. This is called trans isomer. If you take the example of PT NH3 Cl2, this complex. If you take this complex, question asks you whether this complex will exhibit geometrical isomer or not. At that case, we have to answer that is PT NH3 Cl. This is cis form, and this compound will be PT NH3 Cl opposite direction, Cl opposite direction, NH3 opposite direction, that is called trans. Then any compound in combination of 4 having the type Ma2B2 type will exhibit two isomer, that is one cis and another is trans. Another type is M, A, B, C, D, where 4 ligands are different. If the 4 ligands are different, M in square planar, A, B, C, D, where A is the ligand, B is the ligand, C is the ligand, D is the ligand. 4 different types of ligands are there. At that case, what we look at here, M, A, B, C, D. One form like this, we get like this. When A to C, we can write other form also, keeping A constant, M, A, would take here B. B comes here, C, D. One form, second form. Also, again, now we can get M, A, B was there, D was the C. C comes to C to this place. M, A remain there, here C, that is B, that is C, and we may write this like D, B. So we get 3 isomers. If the 4 ligands are different in coordination of 4, having square planar complex give 3 isomers, 3 geometrical isomers. Now we will discuss the coordination number 6. Coordination number 6 of geometrical isomer. Number 6. So the structure is octahedral type, like this. The structure is octahedral. M, 6 positions are there. 1, 2, 3, 4, 5, 6. 6 corners are there. Now in M, A6 type, whether will give geometrical isomer or not. Example is CO NH36. Whether it can give geometrical isomer or not. +3. Now A is ligand, so NH3, 6 ligands are there, MA6 type, only get one structure. M, A, no other structure. Therefore, the type MA6 type, where M is the central metal or metal atom or ion, A is the ligand. In that case, we will get only one form, one structure. So therefore, do not give geometrical isomer. Do not give geometrical isomer. Then Ma5B. Ma5B. Example is Cr NH35 Cl Cl2. So this is the ligands. A is ammonia, B is Cl. Only we get one structure here also, Ma5B, M, A, जितने बुले ले जितने चेंज कर ले 5A remain one side and 1B remain one side. No change. No, we get different. We do not get different structure. Hence, it does not give geometrical isomer. Question पचाला मन करो. This compound whether give geometrical isomer or not. You will tell that it will not give geometrical isomer because we get only one form, one structure. No other structure you can find. Now Ma4B2 type. Ma4B2. 4 ligands, similar ligands, and the 2 are different ligands. B2. CO NH34 Cl2 plus this compound. So this is A and this is B. In this case we find here M Cl NH3 NH3, we get two forms, we get NH3. So these two chloride remain one side and 4 ammonia remain on other side, therefore it is called cis form. Now here M NH3 Cl NH3 opposite direction they are remain. You may write Cl to Bb, Cl Bb, we write Bb, NH3 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 NH3. This Cl and Cl are in opposite direction, so it is cis form, it is trans form. Therefore this compound whether will give geometrical isomer or not, you will speak that it give one cis form and another trans form. The trans form, that is trans because the two chlorine atoms remain in opposite direction. Here these two chlorine atoms remain in the same direction. Same direction means cis, opposite direction means trans. Another example is Ma3B3. Ma3B3 type. In the Ma3B3 type, 3 A ligands, 3 monodated ligands we are taking A and 3 B. Example you may write Cr NH3 3 Cl3. Total is coordination number 6 plus this state. So this complex is there, and in this complex we get the isomer like this. Cr NH3 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 Cl Cl Cl. This is one form. 3 ammonia one side, 3 chlorine other side. Another form we get like this. NH3 NH3 Cl Cl, one NH3 Cl. There are two forms. One is facial, the same face, one remains on same face. It is called other is more median. Same median more. It is called face. Facial face, and that is called more. We get this type of geometrical isomer of these compounds. Ma6 type, Ma5B type, Ma4B2, Ma3B3 type, because here Ma3B3 type. Now, bidental ligand, let us use some bidental ligand. Bidental ligand, dental ligand. Example is ethylene diamine. Ethylene ligand is ethylene diamine. In that case, ethylene is mentioned En. That is written as En. That is NH2, CH2, CH2, NH2. One molecule can link in two positions, hence it is called bidentate M, like this. So in this case, for example, MEN3 type bidental ligand, by MA, we may write this bidental ligand A form, we may write MA3. In the MA3 type, we get like this. These two positions, it occupies two positions. Let us take it occupy these positions, these two positions, and this makes me write like this. 2 positions. Here it occupies 2 positions, here 2 positions, and this is 2 positions. Here is NH2, CH2, CH2, NH2. Here is NH2, CH2, CH2, NH2, like this. Here is NH2, CH2, CH2, NH2. Simple way we may write in the form, only En form we like this. If we keep this position, the other position will be this, and this position will be this. En, En, and En. Bideligand, 6 positions are there. Both En remain same side, therefore it is called cis form. Because this En and this En remain same side, and another En is even that side. If of this M, we may write this. En we may write like this, M bidental ligands. Cis form and like transform. Transform like this, these 2 positions are En. You keep these positions En. Then NH2, CH2, CH2, NH2, NH2, CH2, CH2, NH2, because bonding test by NH2. And the rest was that's En. May write this En. These 2 positions. So this is form transform. If transform is symmetrical, because you take a mirror there, this is the image mirror of that one. But cis form, this is cis form. A question may be asked whether CO En2 Cl2 complex will exhibit geometrical isomer or not. Compare, you may compare En is bidental ligand. You may write this formula COA2 B2 type. So in this type we take like this. So this form B and B opposite direction M is there, and this is your En, this is your En. This here you may write Cl, you may write your B position is Cl like that. Like the Cl and Cl, En and En, opposite direction, this is called in the transform. If this form is M En Cl, this is your cis form. One is transform, another is cis form. So this is all about geometrical isomer. Now optical isomer, which can rotate plane polarized light. We may compare this compound M En3 compound. This compound we get like En, M, En, En. Or we write the example is CO En3 Cl3. So first this compound whether give geometrical isomer or not, we will find out. M En3 type, but CO En3 gives geometrical isomer. Because here one is this is cis form En, En, En. It is cis form, and this form is CO. We write En, En, En. Among this, due to symmetry and it due to not symmetrical, therefore if we get a image, mirror, we get image of this. I can show you. Again it can resolve 2 isomers. The cis form can resolve into 2 isomers which are called optical isomer. It can rotate the plane polar light like this. M En Cl Cl. not superimposable. तो ऊपर रखले तो ऊपर पूरा पड़िबनी get like this. M N ठीक जम ना मैं ओइनार मुंह देखन ठीक सही बढ़िया एटा देखा जो like this Cl Cl ताको दे मैं आनिक superimpose करबा आसी एटा ऊपर आ जीवो. So this is the optical isomer. The cis form can resolve into optical isomer. Transform cannot resolve into optical isomer. So this is all about your isomerism. Now I will go to the most important factor, important bonding, that is your valence bond theory, bondings in VB theory. Valence bond theory of coordination compound. केमिति bond करे, केमिति formation compound करे. केतरा fundamental जिनिस हम देखियो पड़िबा हमकु. Number 1, ligand. First we go to ligand. Ligand contain lone pair of electrons, LP electrons. Lone pair electron remain in orbital ochtaro. Remain in orbital. The second point, metal is there. Metal is d orbital. S orbital, বিভিন্ন orbital is d, s like this. It is hybridized. Metal orbitals first hybridized. Then the hybridized orbital, number third point, the hybridized orbital, मैं बुझे भी डिटेल. Hybridized orbital of metal overlaps with the ligand orbitals. Ligand orbitals forming coordinate bond. So hybridization may be coordination 4. Suppose CN4. The two types, one is sp3, other is dsp2 hybridization. sp3 or dsp2 hybridization of the metal. If coordination number is 6, we get coordination number is 6, Cn is 6, we get either D2sp3, that is n-1, ns, np, or we get n, D2, ns2, s, np3, n, so n. This is called outer orbital complex. And this is called inner orbital complex. What outer and inner orbital काइंग होची बुझेई तापरे. ताले वर्तमान बॉन्डिंग ता हला वर्तमान फर्स्ट बॉन्डिंग रे लिगैंड रे इलेक्ट्रॉन लोन पेयर इलेक्ट्रॉन अछि गोटे ऑर्बिटल अछि. सी आसी ओवरलैप करिवो हाइब्रिडाइज्ड ऑर्बिटल ऑफ द मेटल. लेट अस डिस्कस सम ऑफ द कॉम्प्लेक्सेस. Suppose you take nickel tinta naban NiCO4, NiCN4, NiCl4. Let us discuss the structure of these compounds having coordination number 4. First, we discuss NiCO4 complex. In the study of NiCO4, the lone pair electrons available in CO, oxygen atom. So these electrons available here overlaps with nickel. Ni atom number is, this carbon is there, 28. Electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. हम गोटे स्ट्रक्चर के पूर्व आम देखा ऑक्सीडेशन में केते अछि. फर्स्ट ऑक्सीडेशन ऑफ निकेल इज सपोज x, CO is neutral, x plus 0, there is no charge, that is equal to 0. The nickel remain in 0 oxidation state, 0 oxidation state. Nickel प्रथम देखा आगे फाइंड आउट ऑक्सीडेशन स्टेट लोकल कर परिबा नै. zero oxidation state. If nickel remains zero oxidation state, what happens? So 3d8 4s2, the ground state. 3d8 the 5th orbital 1 2 3 4 5 3d8 1 2 3 4 5 6 7 8 and 4s2 3d 4s, remember that's 4p 1 2 3 4p. So hybridization takes place 3d 8 4s2 4p, because there is nickel zero state, it is called ground state. Ground state. Since C a very strong ligand, so कौन करे pairing करियो एठी. Pairing हला परे this will be 3d10 and 4s 4p. Four S, 4 and P, 3D. Then comes d orbital is filled up, 4s is there, near energy 4p, 4s and 4p, 1, 4s orbital, 1, 4s orbital and 3, 4p orbital mixed together to give sp3 hybridization. sp3 hybridization, because nickel is in zero state here. After sp3 is CO orbital, CO lone pair overlaps with the 4s, giving these 2 electrons here. Dot dot dot. So these electrons comes from the ligands. So the hybridization takes place sp3 and the structure is tetrahedral. NiCO4, the structure is tetrahedral. If sp3 hybridization, tetrahedral. Then question is whether paramagnetic or diamagnetic. You see, there is unpair electrons, that is paramagnetic. If all are pair, no unpair, but no unpair electrons, no unpair electron, that is diamagnetic. Now come this compound. This is filled. There is no unpair electrons. Therefore, NiCO4 is diamagnetic. But why? Question was asked you, why NiCO4 is diamagnetic? Explain. The diamagnetic because it does not contain any unpaired electron. All orbitals are filled up. Now we discuss NiCN4. So therefore NiCO4 is tetrahedral. NiCO4 structure is sp3 tetrahedral and it is diamagnetic. Now we discuss NiCN4. What happened? NiCN4. NiCN4 complex NiCN4 minus 2. And this complex Ni state, let us see, X plus 0 Cn minus 1 minus 4 is equal to minus 2. Charge remains minus 2. So X minus 4 is equal to minus 2. Charge remaining minus 2. So find out the oxidation number will be, X will be plus 4 minus 2 equal to plus 2 state. So nickel remain here. The oxidation number of nickel, oxidation number of nickel is +2 state here. এইটা নহলে ভুলে যাও সব নিকেল দি +2 ভাইলা আমর অঙ্ক করিবা সেমিতি 3d8 4s2 আগে করছিলাম আমি 3d8 4s2 ground state nickel eta. So nickel +2, the electron can remove from the outermost shell, that is 4s2. So remain 3d8. 1 2 3 4 5. (3d8) here is S, here is P orbital. 3d 4s 4p. Now Cn is very strong ligand, it is capable of preparing. So कौन करियो Cn ligand जोटा भैलेंसमेंट तेरे बुझे पाला नहीं ताको क्रिस्टल पर तेरे बुझेला चला बुझे पाना तेला 3d8 like this, the ground state Ni2 plus, and this XII state will be 2 1 d orbital and vacant S and P. So the hybridization will be Cn, each Cn minus gives 2 electrons, gives 2 electrons. So the hybridization is here dsp2 and it is square planar. This is your square planar. All dsp2 is square planar, sp3 tetrahedral. Then comes whether it is paramagnetic or dimagnetic. So all the orbitals are filled up, there is no unpaired electrons, therefore it is dimagnetic. The nickel Cn4 is also dimagnetic. Question पचार था तो गोटे वर्ष पढ़ता NiCO4, NiCN4 and NiCl4. Write the structure and their magnetic nature. ताले NiCN4 we discuss. The structure is square like this. Cn minus. It is square planar structure. Here it is dimagnetic because it does not contain unpaired electron. All are pair up. Dimagnetic. Now last NiCl4. Minus 2 NiCl4 2 minus. Here also nickel remains oxidation state, oxidation state is +2 because X minus 4 is equal to minus 2, X is equal to +4 minus 2 is equal to +2. So +2 state means 3d8 4s2. Since nickel remains +2 state, therefore 3d8, there remains 3d8. 1 3d8 S P 3d 4s 4p. In the 3d 4s 4p, because chlorine is very weak ligand, se kon karibo se pairing kari pariboni. Jodi pairing no kari paribo, here hybridization takes place 1 4s and 3p. It is formed sp3 hybridization. Cl minus gives here 2 electrons, Cl minus. Here the structure is Cl minus, NaCl minus. The structure is tetrahedral. Here NaCl4 is tetrahedral. Like this, tetrahedral. NaCl, Cl, Cl, Cl. Tetrahedral. Then question whether paramagnetic or diamagnetic. You see here, this is one lone pair and this is another lone pair. It contains two lone pair electrons. Therefore, it is NaCl2 minus is paramagnetic. Paramagnetic. But a question pare. Nickel Cl4, NaCl4, 2 minus, and NaCl4, 2 minus, having nickel plus 2 state, whereas one is diamagnetic and one is paramagnetic. It is diamagnetic and it is paramagnetic. Explain it. You can explain by this way. Then go to the coordination number 6. Coordination number 6. Bondings in coordination number 6. Coordination number 6. In the coordination number 6, we may write the cobalt structure. Cobalt, example NH36 plus 3 and COF6, both case 3 minus. हम दुईटा स्ट्रक्चर कर देखा कौन डिफरेंस अच्छे सेम अच्छे कौन अच्छे. Here cobalt remains which state. Let us discuss the structure of CO NH36 which remains plus 3 state. Plus 3, that is X plus 0 is equal to plus 3. Cobalt remains as plus 3 state. Since the cobalt remains plus 3 state, its configuration will be 3D 7 4s2. 3D 7 4s2. We may write this 3D. Here is 1s like this, or 1s2, 2s2, 2b6 like this. That is, you may write argon. You may write argon like this. 3D 1, 2, 3, 4, 5, 4s2. 3D 7, 1, 2, 3, 4, 5, 6, 7, 4s2. Now cobalt remains plus 3 state. That means 2 electrons removed from outermost shell, that is 4s, and 1 electron from d orbital, that is 3d6. 3d is configuration like this. 3d6. 3, 4, 5. 1, 2, 3, 4, 5, 6. 3d6, 4s, 4p. 1, 2, 3. 3d, 4s, 4p. Now since there is 2, 3, 4, 6 electrons are there and the ammonia ligand there. Ammonia is almost a strong ligand. It कौन करिबो ए जो छोटा अछि आपको पेयरिंग कर देला. Pairing कला परे it will come like this 3d6. It will come like this 3d6. 2, 3, 4, 5, 2, 3d6, S, 3d, 4s, 4p. Since there is 6 ligands, ammonia is 6 ammonia अछि. जेतु 6 ammonia अछि से कौन करिबो 6 electron pair दला कि ammonia NH3 first is gone to this hybridized D2 sp3. D2 sp3 means that D2 dita D gota S tinta P. This pair of electron like this. It comes from NH36, NH3, 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 NH3. So the structure will be here D2 sp3 hybridization. D2 again D, D2 sp3. Since it is n minus 1 D, it is 4, it is 3. 3 means 4 minus 1, 3. It is n, this is n. So this is called inner orbital complex. Inner orbital complex. What is inner orbital complex? So the bitter data number, that is called inner orbital used, inner d orbital, n-1 d orbital is used for hybridization, that is called inner orbital complex. Therefore, CO NH3 plus 3 is dimagnetic because no unpaired electron, and it is, the structure is octahedral like this. CO NH3 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 octahedral and dimagnetic. Tinta kata, it is octahedral. Hybridization is D2sp3. It is dimagnetic. Dimagnetic. Now this will compare this compound, hexafluoridocobaltate compound, hexafluoridocobaltate 3 complex. In the COF6 3 minus, COF6 3 minus, cobalt remains, to cobalt is x minus 6 is equal to minus 3, x is equal to plus 6 minus 3, that is plus 3 state. Cobalt plus 3d7 4s2, 3d7 d7 कर दो जे 2 3 4 5 1 2 3 4 5 6 7 3d7 4s2 and 4p is there, 4p 1 2 3. Now my point is, cobalt in plus 3 state, 2 electrons goes from the outermost orbital, 1 electron from this, 3d remain 3d6. Yet in the place of cobalt plus 3 state remain as 3d6. 3 1 2 3 4 5 6 S P triple SP 1 2 3 5. Look at here, 2 3 4 5 6 रहिला बर्तमान 3d6 and s orbital, this fluorine very weak ligand. ये कौन करिवा आपको पेयरिंग करि परिबोनी, जदि पेयरिंग न करि परिबो से इलेक्ट्रॉन का एज यूजुअल रहिले ताले हाइब्रिडेशन हबो sp3 एटा ला दिस इज 3d 4s 4p 4d 4s 4p 4d. So electron comes from fluorine F minus, here 2 electrons 6 fluorine give this D2 sp3d2 sp3, this is sp3d2, it was p orbital sp3d2. So this is the 4s 4p 4d, this is called sp3d2. Today we came D2 sp3 hybridization. One is D2 sp3 and another is sp3d2. That is the one is, that is called outer orbital complex. This is called outer orbital, and that is called inner orbital. C1H36 inner orbital and this is outer orbital. Similarly, we can explain why potassium ferrocyanide. This is one question for you. Potassium ferrocyanide is dimagnetic. You can explain by this way, whereas potassium ferricyanide is paramagnetic. We can explain by this method, magnetic. Then we'll go to the crystal field theory. In the crystal field theory, based on the repulsion between metal electrons with ligand electrons. Ko jagara repulsion besi habo ame dekhiba. Ligand electrons. Ligands are assumed to point charge. Ligands are assumed to be point charge. Ligands assumed to be point charge. So the ligands of this, when the ligand approach to each other, d orbital has dxy, the x-axis and y-axis, this is dxy. Similarly, xz, dxz, another is dyz. Dx square y square, dz square. You look at here, these remain between the lobes. X, y remain between the axes. Here x, z remain, lobe d orbital remain between the axes. It is remain between the axes. It is between the axes. And it is along the axis. Along the axis. So this remain between the axis, repulsion of the ligand toward the metal will be less here. Repulsion of electrons will less, it will be high. Due to more repulsion, it will take high energy. Basing on this crystal field theory, we may write the d orbital can split into first d orbital degenerates there 1, 2, 3, 4, 5 d orbitals. Again, the field high energy goes to high energy 1, 2, 3, 4, 5. When this, we may find this. It is, we give 3 and it gives 2. So this is in the spherical charge, sphere of charge rahila. Etala only m metal m3 plus d orbital, or d orbital, only d orbital, simple d orbital. T2g, you give T2g and EG orbital, 2 energy. And the distance with the energy gap can be explained by del O, octahedral. O means octahedral. Suppose D1 is there, the electron goes first here, D1, D2 goes here, and D3 like this. In the octahedral case, this. In the tetrahedral case, it will be, in the tetrahedral, means reverse. Tetrahedral will give this. And this is the minus 2 by 5 del O. It is plus 3 by 5 del O. Tetrahedral case, EG, E and T. So the reverse is there. So this is distance between this is del T, tetrahedral, del T, and the del T, it is del O. If del O is equal to, we may write simple word 10 dq, we may write del O is also 10 dq. Suppose the electron low spin and high spin, but this distance energy depends on spectrochemical series. One is spectrochemical series I minus, Br minus, Sn minus, Cl minus, S minus, F minus, like this. But series is there. The splitting of energy like this. If pairing energy is greater than del O, pairing energy is greater than del O, that means this is less. At that case, it will favor high spin complex. High spin means first this fill up, again go to this, not pairing hyperonic. If P is less than del O, then we get low spin complex. So one high spin and another is low spin. because easily we get pairing of electrons. Suppose D1 was there, D1 is there. In the D1, it will be like this: D1, 3 and 2. Electron first go to T2Dg, like this. So this is all about the bondings and isomerism of coordination compounds. Okay, thank you.